Well, I apologize that I can't be with some of the classes today, but I want to talk a little bit about how to graph exponential equations. Now, first off, it's exponential because the variable is in the exponent. So these have a couple characteristics that we're going to look at with these two. We're going to do a very, very basic one, and then we're going to go from freshman right into varsity. So one thing I'm trying to do is make your life convenient. If we're going to have an exponent, we understand that that can get really, really large or really, really small very fast. So I've selected -2 to 2. Now these, hear me carefully here, these are the numbers you want your exponent to be. Okay, remember the wording there. You want your exponent to be -2 to 2. It'll help you see the curve today. Now I'm going to start with the easy ones, right? And we'll work our way to these negatives that some of you may forget how to do. If I plug 2 in, 3 to the second, 9. 3 to the first, 3. Now remember, 3 to the 0 is not 0, it's 1. Okay, this is where some of you forget what to do. If I have 3 to the negative first, what happens with the negative exponent? It moves. So 3 to the negative first is 1/3, and 3 to the negative second is 1/9. Okay, very, very basic, but you have to be able to evaluate. Now, when we plot these points, we're going to see something that's kind of interesting and very unique to exponentials. At -2, I'm at 1/9, so just barely above. At -1, I'm at 1/3, so maybe a little bit further up. Okay, at 0, I'm at 1, now we're talking. At 1, we're at 3, and 2, we're way up here. Okay, now I want us to understand something. Some people, if they draw this graph too quickly, they're like, okay, it's just going down. No, it's not. It is approaching something. Because think about it. -2, we're at 1/9. Well, what about -3? Think that's 1/3 to the third, 1/27. If you keep going with that, it's 1/81. And it continues getting really, really, really smaller numbers, but you understand it'll never cross 0? Because if you raise any number to an exponent, it will never equal 0. So this is where we see our first asymptote. It is a line that our graph will approach but never touch. It's like exhibits at the museum. You can get really close, but you can't touch them. Same thing with an asymptote. Now remember what I said? I said the equation of a line that we approach but do not touch. So when we start talking about the asymptote later, it's not a number, it's an equation of a line. Remember that. So you can kind of see it here. What are we approaching? We're approaching 0. We're never going to actually touch it though. So what I want you to do today is put a dotted line where your asymptote is, and then you can better draw your curve. You're going to always be getting closer and closer but never touching, and then up, up, and away. And that is a quick look at what your graph for any exponential should look like. Keep in mind, if you are going to be multiplying by a negative after your exponent, it's going to invert it, right? We're going to flip across the x-axis. That's okay. Now we're going to look at one that's a little more advanced, but it has the same properties. Now I've left the xy chart blank for a reason. We have y equals 2 to the x plus 2 minus 4. Remember those words I told you earlier that I said are really important? Well, they're important. And I told you I want my exponent to be -2 to 2. I did not say I want my x value. There's a difference. Because now I have to select x values that will make a -2, -1, 0, 1, 2. So the first value that I should plug in for x is -4. Hopefully that makes sense. Do you understand that plugging -4 into x will give me my exponent of -2, which is what I wanted. So to get a -1, I would need -3. To get 0, I would plug in -2. To get a 1, it would be -1. And to get a 2 up here, it'd be 0. I need to see at least 5 points on every graph. Select values that give you a -2 through 2 in the exponent. All right, now we just evaluate. Now be careful, some of you are still struggling with this. If I plug in -4, I'll show the entire process for the first one. If I plug in -4, that'll be 2 to the -4 plus 2 minus 4, which gives me 2 to the -2 minus 4. That is not -4. That is not -4. That is 1/2 squared, which is 1/4. Right? Because if that's negative, it goes to the bottom, then it's 1/2 squared, which is 1/4. Now from here, you should get common denominators. That's why I'm not here today. you should be able to get common denominators and combine. Your final answer will be negative 3 3/4. Okay, you'll do that for every single problem. When you plug in negative 3, you get negative 3.5. When you plug in negative 2, you'll get negative 3. Plugging in negative 1, you're going to get negative 2. And when you plug in 0, you're going to get 0. Now, if you don't believe me, evaluate. I'm just doing it for speed today so that you can see the result. Now, a couple things about this. When I plot my points, negative 4, negative 3 1/4. Almost a negative 4. Negative 3, negative 3 1/2. So maybe a little bit up from there. Negative 2, negative 3. Okay, we're starting to climb. Negative 1, negative 2. All right, bigger increase. And then 0, 0. So you can start to see it again. But again, what are we getting really, really close to? Hopefully you can see it. We're getting really close to negative 4. There's a negative 4. What we get close to over here? We got close to 0. Well, but there's nothing over here. Okay, well, let me ask you something. What do you see how you're subtracting 4 back here? What are you doing back here? Common response, nothing. Okay, what's the number for nothing? Yeah. That is where you're going to get your horizontal asymptote from. So here, my horizontal asymptote is negative 4. So when I draw my curve, I will approach, but do not touch the negative 4. So an easy way to remember it, whatever is being added or subtracted at the back is your horizontal asymptote. But to be more specific, when you have a horizontal asymptote, it has to be the equation of a line. What's the equation of this line? Y equals 0. What's the equation of this line? Y equals negative 4. If you just put negative 4, you are just wrong. It has to be the equation of a line. All right, last two things, domain and range. Domain, left and right, is the x values. One thing nice about these exponentials, will this ever stop going left? No. Now a lot of people say, well, it's going up. Okay, it's going up and right. Will it ever stop going up and right? No. So our domain for both of these is negative infinity to infinity. Lastly, the range, up and down, y values. Clearly we have stopping points here. Remember, it is the least answer to the greatest answer, smallest to greatest. So when I look at my range here, clearly we are approaching 0 and going to infinity and beyond. So it would be from 0 to infinity, but it is a parenthesis, not a bracket, right? Bracket's only when you capture something. We just stated you'll never be 0, so it has to be a parenthesis. And over here, follow suit. If it's a range, we are approaching negative 4 and then going off into infinity. Quick little help. Hopefully this gets you going on the worksheet for graphing exponentials.